Good morning, students. Today we are going to be dealing with the properties of exponents. The properties of exponents. So, to start us off, I would like to remind you how exponents work. So, on the side of your book, let's take a look at exponents. Let's do 3 to the 1 power. 3 to the 1 power equals 3. How about 3 squared? What does 3 squared equals? Well, it's 3 times 3, right? 3 times 3, which is 9. How about 3 to the 3rd power? Lots of times students will be 3 to the 3rd power, that's 9. No, it's 3 times 3 times 3, which is 27. 3 times 3 is 9. 9 times 3 is 27. And 3 to the 4th power, well, that's 3 times 3 times 3 times 3 times 3, which is 81. Now, what if we go this way? Uh-oh. What happens to exponents when we go this way? Well, 3 to the negative 1. Whenever you have a negative exponent, you're going to be dealing with a fraction. And I'll show you. So if you ever see a negative exponent, go ahead and just write your fraction. Just write your fraction line. And what this does is it takes that number or variable to the opposite side of the fraction line. So 3 to the negative 1/3 is just the inverse of this. So negative 1, it's the inverse of 3 to the 1, so we would have 1/3. So about 3 to the negative 2. Well, it'd be 1/9. It's the inverse of this one, 1/9. So 3 to the negative 3, 1/27th, and 3 to the negative 4 would be 1/81. Now, I left one blank right here. 3 to the 0 power. 3 to the 0 power is actually 1. So, that's just a general rule. Just remember that. 3 to the 0 power is 1. 3 to the 1st power is 3. 3 to the 2nd power is 9. So, there's exponents for you. And we're going to be dealing with some negative exponents today. But that's a quick overview of simply exponents. And let's review how we deal with exponents. 2 to the 2nd power times 2 to the 3rd power equals 2 to the 5th power. How do I know that? Well, 2 to the 2nd power is 2 times 2. 2 to the 3rd power is 2 times 2 times 2. So, what I have is 2 to the 5th power. Well, what is 2 to the 5th power? Well, let's check. 2 times 2, 3, 4, 5. 32. Now, how would I check that if I just wanted to do it out? So I should have just done it here. 2, 3, 4, 5. If you don't have a calculator, what you could do is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So there's your answer, 32. All right. So about 4 to the 1st power times 4 to the 5th. Well, I have 4. 1, 2, 3, 4, 5. 4 times 4 times 4 times 4 times 4 times 4. So that's 1, 2, 3, 4, 5, 6. So that equals 4 to the 6th power. So do you see a pattern here? I'm adding these exponents. 5 plus 1 is 6. 2 plus 3 is 5. So I'm adding the exponents. 4 to the 6th power. You know what? I'm going to go in here. I'm going to use Desmos. Let's get to a regular calculator. Or scientific calculator. And we'll do 4 to the 6th power. 4,096. It goes up pretty quickly. So right here, what do you get? Well, we get 5 to the 8th. 3 plus 5 is 8. And 5 to the 8th, if I go over here, and I go 5 to the 8th, I get 390,625. Oh, we have variables here. X squared times x to the 6 is x to the 8th. And that's as far as I can go. Alright, now what about if I have dividing fractions? So that was all multiplying multiplying exponents. What if I'm dividing exponents? Well, this is 4 to the third, so 4 times 4 times 4 over 4 squared, 4 times 4. If you remember from dealing with fractions, if I have the same on the top and the bottom, they cancel each other out. So this equals 4 to the 1, or 4. I wonder if we'll find a pattern here. 1, 2, 3, 4, 5. 1, 2. So I have 2 to the third. 2 times 2 is 4. 4 times 2 is 8. So let's look at this. Oh, 5 minus 2 is 3. Oh, so division of exponents, I subtract. Multiplication of exponents, I add. When you multiply exponents, add the exponents. So if I have x to the a power times x to the b power, then I would have, sorry, it's getting very crowded here, I would have x to the a plus b. And likewise, down here, I would have x to the third, right? Because 6 minus 3 is 3. And here, look at that. Here's a great explanation of how 3 to the 0 power is 1. 4 minus 4 is 0, so this is 3 to the 0 power, right? And if I did it, 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. Cancels, 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 cancels. So I get 1. I don't get 0. I don't get 0. If, let's take 3 to the 4th power. So 2, 3, 4. So I have 81. 3 to the 4th power is 81. Over 3 to the 4th power is 81. Anything over itself is 1. There's your mathematical explanation for this. Okay, so when you divide exponents, subtract. So x to the a divided by x to the b equals x to the a minus b. So there's your rule right there. That's one rule, and that's another rule. So make sure you highlight those two rules. Okay, and the reason we want to know the difference is because right here, when you're multiplying, when you're exponenting an exponent, you multiply. When you're exponenting an exponent, you multiply. So 2 squared is going to be 2 to the 8th. 2 squared to the 4th power is 2 to the 8th. Because we're multiplying 2 times 4. So if we check 2 to the 8th should equal 2 squared is 4, and 4 to the 4th power equals. Those should be equal. So let's check, and we get 2 to the 8th is 256. and we get 4 to the 4th. So when you're exponenting an exponent, you multiply. I don't know how to say that any differently, but when you're exponenting, this is definitely good. This is top tier math lingo. Exponenting an exponent, you multiply. So if I have x to the a to the b power, I'm going to have x a times b. Okay, exponent and exponent, you multiply. So those should be the three things that you can reference if you need to. A to the x times, x to the a times x to the b equals x to the a plus b. X to the a divided by x to the b equals x to the a minus b. And x to the a to the b exponent equals x to the a times b. So this one would be 21. Oh my gosh. 7 to the 6th power. Come on, math teacher. Okay, so go ahead and do these last two. And just remember the rule. All right. So there's those. The only thing with the 0 power, the only number to the 0 power that doesn't work is 0 to the 0 power. It does not equal 1. So just a little side note. All right. Do those last two. And let's check out some let's check out some of these. So for this one, if you remember PEMDAS, you're going to do what's inside the parentheses first. This applies to the whole parentheses. So 10 squared is 100. Now this, since this is parentheses, this gets distributed to the whole parentheses. So it's 6 squared, a squared. 6 squared is 36, so you get 36a squared. That's how you deal with parentheses. These we can combine within the parentheses, so we have 20 to the 3rd power. 20 times 20 is 400. 400 times 20, 8,000. Is that right? 20. $8,000. So distribute, go ahead and do that one. All right. How about this one? Well, that's distributed through the whole thing also, so you have 2 to the 4th over 3 squared. I'm sorry, 2 squared. I got a little ahead of myself. So you have 4 over 9. So it just gets distributed through the whole equation. So you have 4 to the 3rd power over 3 to the 3rd power. 4 times 4 is 16. 16 times 4 is 64 over 9. X to the 3rd over 2 to the 3rd. X to the 3rd over 8. Go ahead and do number 4. So that's how those work. All right. Moving over to vocabulary. A 0 exponent, anything. 3 to the 0 equals 1. 1,142 to the 0th power equals 1. So you get the idea. Anything to the 0 power equals 1. Now a negative exponent, you always want to think of a fraction. And you're going to move the variable to make exponent positive. So if you have a to the negative 2, that equals 1 over a squared. So I had a negative exponent, but it's positive when I put it in a fraction. Well, what if you have let's say 1 over x to the negative 4. What if you have your negative exponent in the denominator already? Well, you always move it to the opposite to make it positive. So it's x to the 4th over 1. And we all know anything over 1 is itself. So you just move the negative, you move whatever's attached to the negative, you move it to the opposite, to the opposite of the fraction, the top or the bottom. Okay? So if you had a longer one, let's say you had x to negative 2, y to the 3rd, z over z to the 4th, x to the 3rd, y to negative 2. So the first thing I would do with this is I would get all positive numbers. So this x to the negative 2, that's going to have to drop to the bottom, x squared. This y to the 3rd stays up at the top, and this z stays up at the top. This z to the 4th, that stays at the bottom. This x to the 3rd stays at the bottom. So y to the negative 2 moves to the top. So I now have all positive numbers. Now I'm going to combine my like terms. Y to the 3rd times y squared, well, when I'm multiplying exponents, I add them. So I have y to the 5th z over x to the 5th z to the 4th. And now I can simplify because there's one z up here and there's 4 z's here. So I could take it out of this one. So I'm going to be left with 3 z's on the bottom and none on the top. The y to the 5th doesn't change and the x to the 5th doesn't change. So the first step when you're dealing with negative exponents is you're going to flop the negative exponents to the opposite side. Alright. Let's start doing some homework. And I'll do the odds, you get to do the evens. So, what did we learn for 3 to the 0 power? That equals 1. Alright. 3 to the negative 4th power, the first thing I'm going to do is write it with a positive exponent. So it's 1 over 3 to the 4th. And then what I'm going to do is I'm going to take my calculator. I'm going to do 3 4 times. So 3, 2, 3, 4. It's 81. 1 over 81. So the very first thing I did is I moved it. Now, let's see. Okay, here we have a negative. So I'm going to show you this one. This negative is attached to the 4. That negative is what I have to deal with. So what this equals is 1 over negative 4 to the 3rd. So that's how it works. Now don't forget, the negative 4 is the negative is attached to this, so you have to do negative 4 3 times. So it's negative 4 times negative 4 times negative 4 to get your answer. Alright, here, let's fix this one. And by fix, I mean let's get rid of any negative. So I have 1 over 2 to the 3rd, and 5 to the 0 is 1. So I don't even have to deal with it, it's just 1. So 1 over 2 to the 3rd is 1 over 8. I should be putting boxes around my answers. Whoa, what's your answer there? Alright, here we have 4 to the negative 1s. That's going to go down here, 4 to the 1st power. And negative 7 to the 0, that's just 1. So I have to have, if I have a fraction, there has to be something up here. So it's a 1. If there's nothing, it's a 1. So I have 4 to the 1 on the bottom, and then negative 7 to the 0. I know that anything to the 0 power is 1. So I now have 1 over 4. 1 over 4. Okay. And this, I'm sorry, this is actually a negative 1 because of that negative. So 4 times negative 1 is negative 1/4. So that negative belongs in there. All right, let's check out these. Z to the 0 power. What's anything to the 0 power? It's 1. All right. Oh. So we have 3 different things here. We have the 6 times the a to the 0 times the b to the negative 2. So I'm going to do 6. A to the 0 is 1, so I don't even need to write that in there. And then b to the negative 2, I have to write that in a positive. So my negative 2 means it goes to the denominator. There it is. 6 is a positive on top. A to the 0 is 1. 6 times 1 is 6. B to the negative 2 is b squared. 13. Oh, look at this. Fun. So this negative exponent is attached to this 3. So that goes on the bottom, 3 squared. This negative 3 is attached to r, so I have r to the 3rd. And then s to the 0, that's 1. There's my equation, but I don't need that 1 because anything times 1 is itself. So I have 1 over, 3 squared is 9, r to the 3rd. There's my answer. All right, 3 to the 5th over 3 to the 3rd. Well, if you remember, when you were dividing, if you divide, it's a minus b. So it's 5 minus 3, so I get 3 squared. But there's more 3's up top than up bottom. 3 squared is 9. See how much easier it is when you know these rules? Instead of doing 3 times 3 times 3 times 3 over 3 times 3 times 3, I can just do that. Okay. Negative 5 to the 3rd times negative 5 to the 3rd. So, this is interesting. I get negative 5 to the 3 plus 3 is 6. So negative 5 to the 6th value. And a negative multiplied evenly means I'm going to get a positive number at the end. So if I have negative 5 times negative 5, I get positive 25 times negative 5 was 125. So I got negative 5 times negative 5 times negative 5. One, two, three, four, five, 6. So that's a positive 25. That's a negative 125. That negative times a negative is a positive 625. Positive times negative, I'm going to get a negative 3125. Negative times a positive, I'm going to get a positive 15,625. 15,625. Positive. And an easy way to know this would be if I have a negative 6 times, if I'm doing an even number, it's going to give me a positive. If I'm doing a negative number, it's going to give me a negative. 19. All right, now we're down here where we're doing the exponenting of an exponent. So we have a times b. So we look right here, it's a times b. So I have a to the negative 8, which is 1 over a to the 8th. Right here I have the 4, and the 4 is distributed through both of these, so I have negative 4 to the 4th power times d to the 4th power. So a negative to a positive power means I'm going to get a positive number, and then d to the 4th. So my positive number, I do 4, 1, 2, 3, 4. I have 256 6 times d to the 4th. And then right here, okay, so this is 4 to the negative 3rd over x to the negative 3rd. So I have to flip both of these. Or, you know what's an easier way to do it? Is if I have a negative 3rd, I just need the reciprocal. So it's x over 4 to the 3rd. So because they're both negatives, I flip it. So now I have x to the 3rd over 4 to the 3rd. So I have x to the 3rd over 4 times 4. 16, 16 times 4 is 64. Just like that. All right. Finish off 1 through 22 even. And give me a call if you have any questions. Hopefully we're still on the Zoom, so you can ask me any questions while we're still on the Zoom. All right. Have a wonderful day.